Well, good evening, everyone. I hope you've got me okay. This is a new venture for me. I've never done a talk with a slideshow before, so I'm hoping this is going to work. Um, what I'm going to talk about tonight is a little bit about me, a little bit about the boat, a little bit about the experience I had along the way, and then trying to convert from coal burning over to oil burning and the journey that I went through to where I am now. And the picture you see on the screen is Aurelia as it is now today, burning oil, and I have to say, I think very successfully. So to start with, I don't want anyone to think that I'm an expert. I came into steamboating very late in life. Really, it was when I retired that I needed something different.
Good.
I'd spent
Right.
40,
Right. Well, team.
40 or odd years building and flying very large
Well, it's
model aeroplanes.
the peak.
I had been involved with the British Model Flying Association, and I just felt I needed a change. And one day, while I was at an exhibition in the Midlands, I was leaning on a boat looking at the steamboat, and needless to say, John Wynne sidled up to me and said, "Do you like that?" And I said, "Yeah, well, yeah, okay, yeah." But if I'm honest, what I was
Oh, very
really
good.
interested was more about building an
I've
engine,
clicked on it again, and
more about building an engine than building a boat. John very kindly offered to loan me the engine in his boat, and over the next year, we've gone out of sequence here. That's a bugger. Oh, there we go. Over the next year, I built one of his V twin engines. I wasn't at the time really looking to build a boat. I was really looking to do some engineering. I'd got a small lathe, I'd got a small mill, and I just wanted a change. And a steam engine seemed to be a great idea. Of course, once you build an engine, you then think, well, what the hell am I going to do with it? And really, by visiting the crowd over at Abingdon a few times, made me realise that perhaps I'd like to build a boat. And I have to say that the crowd at Abingdon, which was affectionately known as the Thames Mafia, made me so welcome and took me out in their boat and showed me steamboating that I guess I was hooked. You know, it's one of those things that you sort of build into, and I was hooked. So to cut a long story short, I'm going to have to flick back now. I'm sorry about this. I started doing some research, and I found a hull that had been designed by the SBA called the Sylvie hull. It was available from Mike Bell, and so I bought the hull. I brought this thing home and started doing the woodwork on it. Still really not having much idea of what I was doing, because I say I'd never been involved with a steamboat before. I was very lucky, really, in that someone in the SBA offered me a fire tube boiler. I made some mistakes along the way because I was offered two boilers. One was a water tube boiler, what I call a dog kennel boiler, and the other one was this one, which was a fire tube boiler. And in retrospect, foolishly, I'd got this idea that a steamboat had to have a vertical boiler with a nice big brass dome on the top and a funnel. So I rejected the water tube boiler, and I was given this boiler, which was a VFT 101, I think. And I started working on it to get it into my boat. It worked very well. It was coal fired. It was easy, really. I say it all worked rather well. Now I'm going to go back because I think we're now back into sequence. Right. So I did about 2 or 3 years burning coal with that particular boiler. It all worked very well. I have to say I probably wasn't the best person at managing a boiler. And the few times that I managed to shower my wife with black soot probably didn't go down that well, and led me to believe that perhaps I ought to adopt the. It led me to start looking at what the Abingdon people were doing, which was burning oil. It struck me that, bear in mind that I was by then going out with the Abingdon crowd. They were all in oil and I was in coal. And we used to go out as a flotilla, perhaps up to 4 and 5 boats at a time. It all seemed for them very relaxed, very easygoing. They didn't have to mess around with carrying coal. They were, when we got to a pub, they just turned it all off and we went to the pub. And there was me trying to manage a fire and keep everything going. And when we got back, my fire had gone out. So it sort of started me thinking that perhaps the direction to go in was to convert my boat over to oil. John and Ian McAlpine very successfully were running pot burners. I hadn't got a clue what a pot burner was. But again, I picked their brain and took pictures of what they were doing and came up with this design of a pot burner. Not my design. It's something that I think is probably pretty standard. I found myself something like a 10-inch stock pot. So the outer pot that you can see there is made up of a stainless steel stock pot. I think I got it from Costco, if I remember rightly. And I got a friend of mine to make me a inner pot that dropped into the external pot. The inner pot had a series of about 43mm holes drilled tangentially around the pot. And you can see there at the bottom a tube into the outer pot with a fan. Now, I have to say, I hadn't got a clue what I was doing. I made this thing, and what you're seeing there on the picture was the very first time I lit it. You can see it's in the garden, not in the boat. I strapped onto the end of it a bilge blower, and I lit it. And unbelievably, that was what I got. For those of you who don't know about pot burners, it's an odd flame arrangement, really, in that the flame is like a tornado in the middle of the pot, but suspended in midair. It's not burning anything. It's not burning wood. It's not burning any form of material. It is just burning oil itself. And it swirls around and round in this sort of tornado effect, suspending in midair. So I was pretty chuffed with this, and probably sent pictures to everyone saying, hey, look what I've done. The next stage was to try and fit that into the boat. And what it meant doing was making a new sole plate for the boat. The sole plate, if you like, is a 6mm thick stainless steel plate with a big hole in the middle. The big hole that you can see there is the outer pot of the pot burner, and you can see the tube coming in that is the air, the fan tube. So again, a friend of mine, well, in fact, I had that big lump of stainless steel cut. I had that ring welded on, which fitted the bottom of my boiler. And again, it all looked as though it was going to work. Now, the first thing I noticed, sorry, let me just look at this a minute. Right, yeah. Right. Okay. Now, obviously, to convert from coal to oil, I did away with the coal bunker that was at the side. That next stage meant I had to make a fuel tank. I had this stainless steel tank made, this fuel tank, which I pushed up into the bow of the tank of the boat. I decided that I would try and have a fuel tank big enough for an SBA rally. And I sort of worked on the basis of that, of a couple of hours on the Friday, a Saturday steaming and a Sunday steaming, and then come home. So I actually worked on that. I wanted a tank big enough for about 15 hours of steaming. That worked out to about 50 litres. So the tank, which you'll see a picture of later on, had the tank in the bow. Obviously, then there was a bit of pipe work to the pot with a needle valve and a fan. Having a fan means you need a battery. So the installation, in actual fact, was very simple. At the time, I didn't think anything of it. It just all worked, and it was all very simple. The first time I lit it in the boat, I lit it here, and I was surprised at how slow it was to come up to steam. And I couldn't quite work out why, because I calculated that the burner was actually giving me 23 kilowatts. And I calculated that from the hourly consumption of fuel and the BTU rating of the kerosene that I was using. And it worked out to roughly 23 kilowatts. And I thought, well, that's got to be enough to power the engine that I had in the boat. But anyhow, I took it over to Abingdon and we launched the boat and lit the boiler. And yes, it did generate steam, but I think from memory, we got about 1 or 1.5 miles an hour. There was nothing left. There was nothing in the tank. And one of the problems with burning oil is that there is an optimum fuel relationship between the fuel and the air. The air was fixed because it was a standard 3-inch bilge blower, so I couldn't increase the volume of air at that time, but I could vary very much the volume of fuel. So by keep whacking more and more and more fuel in, eventually what happens, of course, is you end up with a huge billowing smoke coming out the funnel. So you have to turn that down until you get a fairly clean burn. And that was the point where I calculated to the 23 kilowatts. So we chugged around. I think probably John was with me at the time. We chugged around trying to think about why we weren't getting anywhere. And the conclusion that we came to was that with a vertical fire tube boiler, or certainly the one I had what I call wet legs. So the water surrounded the firebox and was right down to the grate. And what that meant was that the coal was not only giving a heat upwards through the tubes, but was giving a lot of radiant heat into the legs. Now, the problem with burning oil, as I was burning with a pot burner, is that all the heat was going straight up. There was no radiant heat at all going into the legs of the boiler. And the reasoning we came to was that the heat that was in the firebox was actually disappearing so fast up the tubes that it wasn't being able to be absorbed by the actual boiler itself. I asked around, generally, bear in mind that this was 10 years ago, generally I couldn't find anyone who could give me any idea about a burner for a vertical fire tube boiler. I was committed with the pot burner. I didn't want to go to try and build yet another burner, an atomizer or anything else. So I was committed to the pot burner because I just thought it was such a easy and simple way of creating that much heat. So I started doing experiments, and the first experiment I did was to hang chains. I bought a whole load of chain that just was the same sort of size as the vertical fire tubes that went down the boiler. And I hung a chain down every one of the tubes. As you can imagine, quite a lot of chain. And all I did was put a nut and bolt across the chain at the top, hung the chain down so it went right down into the firebox, and off we went to Abingdon again. Slightly better, only slightly. Not much improvement, I must say. But I wasn't going to give up. So I went home and I got a pal of mine who has a sheet metal works to cut me some stainless steel strip. And the stainless steel strip was just a little bit bigger than the diameter, the internal diameter of the fire tubes. And so by holding one end in the vise and the other with a pair of pliers, I could turn that stainless steel strip into a spiral, and I stopped twisting it at the point when it just went down the tubes. And my theory was that what we were then doing, and I put a nut and bolt across the top again to stop the thing dropping down. And my theory was that the heat now from the firebox had to go up in a spiral through those stainless steel spirals, and would hopefully keep the heat down in the firebox longer. Off I went to Abingdon again, and we tried again. Now, I have to say that was a little bit better, not a lot better, but a little bit. And it was encouraging enough for me to try a double spiral. So in fact, really what I'm saying is I'm clogging the tubes up even more. The problem became then was that the restriction I was putting started blowing back out from the bottom of the boiler. So I obviously put too much back pressure, and it really didn't work. And at that point, I started to get really quite despondent because, I'd spent a year now, backwards and forwards, well, a whole season, actually, not a year, a boating season. I spent a whole boating season trying to make this damn thing work. No one, I asked anyone that could possibly help, have you any ideas? And everyone kept saying, well, I've never heard of a fire tube boiler running on kerosene. Now, I have to say that I know there are fire tube boilers working on kerosene, but they're not vertical fire tube boilers. They tend to be things like locomotive boilers, where perhaps the firebox arrangement and the distribution of heat is different. But certainly I could find no one that's run a fire tube, a vertical fire tube. So I did a lot of soul searching then. I was committed with the boat. I love the boat. The boat itself did everything I wanted of it. It was stable. The family liked it. It could seat 6 or 8 people quite comfortably. So I was committed to stay with the boat, and I was committed to stay with steam because I was hooked on it. So I started really doing some sort of soul searching. John Wynne and Ian McAlpine were both running Oldfelt boilers at the time in their boats. And Oldfelt boiler is that beast. It's a central steel pressure vessel, and around the edge are 20 coils. Now, I realized just how much money I was starting to commit myself to, but I couldn't see any way round staying with the boat, staying with oil. I didn't want to go back to coal. So it just so happened that at one of the Beale parks, That's one of the SBA, a boat show that we used to attend. I took someone out on my boat, and he said to me in the exact words, "If you ever decide to sell your little boiler, I would love it." And I thought, bingo, I'm in business. So I did a deal with him that he would buy the boiler. The funny thing was that his wife was with him, and she said, "You can buy the boiler as long as he leaves the Windermere kettle in place," which I hadn't planned to do because I rather liked the one I made. But anyhow, that's by the by. So I sold him the boiler, absolutely lock, stock and barrel. All he had to do was put 4 bolts. It had everything, all the valves, the Windermere kettle, the dome, the funnel, you name it, it had everything. But it released a bit of money that I then decided to buy a new boiler. I say, John Wynne and Ian McAlpine were both running these boilers. The downside, as I saw it, was that their boilers had copper tubes. And the SBA had come out with this idea that a new boiler with copper tubes is limited to 100 psi. And 100 psi wasn't enough because I was then running a high pressure twin, and I really wanted to play around at around about 150 psi. So I bought the VFT2 plans from the SBAS. I sent them down to Kevin Slater, and I got Kevin to do a design assessment to change the design from copper to conifer. And what you're looking at there is the first VFT2 that was made using conifer tubes. Since then, I've given the design to the SBAS, and it's been replaced, the copper tubes, and it's now conifer. So we set about finding a company to make it. I found a company down in Kent called Steam Technology, and they priced it up, gave me quite a good price, and away we went. But bear in mind that this was a new design, so I had to get the SBAS very much on board. And at the time, the boiler inspector around here was a guy called David Turner. Absolute brilliant guy. I mean, biggest regret is that he retired. And David was wonderful. He came down to Steam Tech with me a number of times. He did all the welding assessment. He got them to do sample welding, sample silver soldering. Absolutely brilliant. I mean, SBAS really did come up trumps. And it wasn't a lot of money. I think, it was only 2 or 3 trips and in my car, and David was brilliant. So this thing came back to me as a pressure vessel with 20 coils around it. I then did a design for a case, which I gave to, or you can see in 2016, I gave to this pal of mine who's got a sheet metal works. And he made me that tin box in stainless steel. Expensive. I think, if I remember rightly, by the time that he'd done everything, the funnel and everything, it was getting on for £1,000. So a big investment. Once you make that decision to change, a big investment. So I put it all together. I put a dry, there we go. I started putting it together, lagged it on the outside. I put a drying coil in the top, not a superheater, a drying coil. And away we went. Now, at the time, I was starting to get a bit inquisitive as to what was going on. I'd had this whole season of disasters with heat, and I thought, well, I really ought to know what is actually happening in this boiler. And I'm, again, a little bit jammy, I suppose. I've got a really good friend here in the village who is an absolute electronics whiz kid. And I was with him one day in the pub. We were chatting away, and I was telling him what I was doing. And I was telling him that really what I'd like to do is to try and fit some form of instrumentation in the boat, which told me what was going on. And he said, well, that sounds like a good project. He said, I'll design it for you. And so we sat and we came up with, hang on. We came up with a specification of that. It's, as you can see, it's just a plastic box, but I fitted around the bottom of the boiler on each of the nodes where the conifer tubes were soldered, silver soldered to the steel nodes on the pressure vessel. I fitted a thermocouple, and we fed those 5 of them. We fed those 5 thermocouples back to this box, and Graham came up with this package of electronics which constantly monitored the temperatures at the bottom of the boiler. It also had an alarm on it, and you can see that little green light there. So I was able to set a node temperature. Now, bear in mind that this is silver solder. I was very concerned that if I got this wrong, I could end up melting out the bottom of the boiler. So I set the temperature at 400 degrees. And if the nodes go 400 degrees, that red light, that little green light turns red, and the hole at the bottom is a little beeper, an alarm. And it was quite interesting. So for the last few years, I've been monitoring what's been going on with this boiler. So we got to the point now where I've got a brand new boiler in the boat. We've got all this equipment all connected up, and I started doing tests. And really, from day one, it's been absolutely brilliant. I was burning about 3 litres of kerosene an hour. The boiler saturates out, that's the node temperature at the bottom, at 320 degrees. So well below the silver solder melting temperature. I can run the boat successfully for a whole day and with no smoke at all. The only smoke that ever gets generated is if I get it wrong, and it can happen if I'm in a hurry and I don't let the vaporizing happen and get the pot hot enough, and you end up putting more oil in than the burner can vaporize, then it is possible you can get some black smoke. But in actual fact, and as John will tell you, if you control the oil flow correctly, you get no smoke at all. And I've now run this boat with, I think, oh, there we are. There's the node joints that I made and the thermocouples. For some reason. Right. So generally very successful, but of course I then had to think about getting a boat certificate for it. So I got my local boat certificate man to come in, and he said, right, the first thing I want is, because you're running now a battery, I want a master power switch, which is that. Then he said, I want I'm probably not going to show you that, a master fuel switch, which is exactly the same, but instead of an electrical switch, it's a valve that you can turn off. All have to be labeled up correctly. Master power, master fuel. And then I started learning some more lessons. At the Windermere 50th celebration, I don't know whether any of you remember that, but the lake was pretty choppy. And I'd been running the boat for, I don't know, 5 or 6 years, and everything was absolutely fine. But I'd never been in really choppy water. And I think what happened is that the boat was rocking around and dipping and diving, shook the fuel tank up, and all the bits of little rubbish that was in the bottom of the fuel tank went down the 10 mil copper tube, and the burner went out in the middle of the lake. Luckily, we managed to get back. It didn't go out straight away, and we managed to go back downwind and got back in. So when I got home, I found it an advantage to fit. Do you know, this is really bugging me. I had all this in absolute sequence. Me and Zoom don't get on, I don't think. Right, fuel. Okay, there's the fuel tank I had made. I'll try. Oh, there's the master fuel isolator that we also had. But when I got back, that's what I fitted directly underneath the fuel tank. And I would say, if anyone even contemplates going to oil, for goodness sake, fit a really good fuel filter, because although I was filtering the fuel going into the tank every time I put another 20 litres into the tank, I ran it through a filter. But I think kerosene, particularly if it's left hanging around, I can only think it sort of grows things in it. Horrible little black stuff that completely clogged up the pipe. So I think it's well worth the effort. I doubt in my mind that anyone can make a vertical fire tube boiler work with oil. But there are an awful lot now of water tube boilers being made, particularly the 3-drum one. I mean, when I look in Funnel, the number of people going over to the John King 2 and 3 drum boilers, water tube boilers, they are absolutely right for turning over to oil, either with a pot burner or with a vaporizer or a Loon Valley. I looked into the idea of running a Riallo boiler, burner, which is the standard burner that a household boiler has. The problem with them is that the current consumption is very high. On a typical Riallo boiler at 12 volts is drawing about 20 something amps, 24 amps, I think it is. And you're going to end up carrying such a massive battery pack to get any duration, whereas my little pot burner only draws 2 amps, and I run a 50 ampere hour lithium battery, and that gives me a whole weekend steaming without any problems at all. So, it's which direction you want to go in, but I'm sold on pot burners. I think pot burners are the way to go. And just to finish the talk, I have now, that just shows that my hull speed is 6.25 miles an hour, and at Windermere I got 6.2 miles an hour running the pot burner, so it works. I have tried a number of different engines. Oh, that's interesting. I'll come back to that in a minute. No, I'll do it now. One of the things that, again, I wanted to know was the energy use on the battery, because I'd been in the early days running a lead acid battery, and I had no way of knowing when I got back from a day's steaming how much energy was left in that battery. So I used to have to cart it home, charge it up, and take it back. Now at Dartmouth, I did that, but our digs were at the top of the hill. So every day I had to carry a lead acid battery from the boat to the top of the hill, charge it overnight, and then take it back down the next day. Not very successful, not very satisfactory. So when I went over to a lithium battery, 50 ampere hour, just the same, only half the weight. I thought, I really do want to know what's going on. And Ian Rutter, who's I think there with me now, is with us now, put me onto this company called Victron. And this is a little battery monitor. It's only about 3 inches in diameter. So in actual fact, in real life, it's smaller than the picture here on the screen. But it's a superb little bit of kit. It tells you the battery voltage. It tells you the capacity of the battery when you start. It tells you the amount of current that you've been drawing, and it will give you a historical history of the current of the battery. But the greatest thing is that when you get back from a day's steaming, it tells you exactly how much energy you've got left in the battery. And now the difference is that I only charge that lithium battery probably every 2 or 3 trips. I trust it to the point where I just don't charge the battery. I just wait until it goes down to about 25%, and then I take it home and charge it. So again, a little bit of information that I added on the boat. Just to finish the boat, I added a little steam pump. It's one of the Southworth pumps. Brilliant little piece of kit. It means that when I get to a lock, when I'm having to wait at a lock, I can just put that on and keep the boiler fully charged. I've, over the years, had something like 5 different engines in the boat. I hope I've got pictures of them, but I can't. I've tried high pressure twins. I've had small compounds. I've not gone for a single, but I've had all sorts of engines. The engine that I've ended up with is a compound. It's built to the same dimensions as a 6A. Probably, if I'm honest, it's a little bit over the top, and I could get away with a smaller engine. I've just changed the propeller, and then that, again, this is an interesting little bit of information. I changed the propeller from a 1624 to a 17 by 30. It dropped the revs of the propeller down from 300 to 400. I've not lost any speed over the water, but I've cut down the fuel to 2.25 litres an hour. Now that I find odd, that you can end up with these sort of parameters. That works out at about £2.20 an hour to run the boat, which I reckon is pretty good going. So there we go. I've gone a long way around it, I'm afraid. That's the boat as it is now, and I don't see any reason to change it. I'm happy if anyone's got any questions, more than happy to try and answer them.
Yes, if people that you can under React, you can stick your hand up. It might be the best way of ordering the questions. Thank you very much, Andy. I have one question. How's the fuel introduced into the burner? Is there a nozzle or some other means of vaporizing?
No, the fuel comes from the tank in a 10mm copper tube. It goes to a needle valve, and then from the other side of the needle valve, it goes to a 6mm stainless steel pipe, which just pokes into the pot burner. And it actually goes in and ends in line with the center of the pot at about 2 inches above the bottom of the inner pot. And in the middle of the bottom of the inner pot, I've got a piece of steel, a steel disc, 3 inches in diameter and 1/2 inch thick. And the oil just literally drips onto that steel plate. And what I found was that before I introduced that steel plate, I was relying on the bottom of the inner pot to get hot. And so that when the oil dripped down onto it, it instantly vaporized. by putting that piece of steel in there, it has more latent heat, and it vaporizes much quicker. So no, it literally just drips. And if you think about it, the rate of drip is 2.25 litres an hour. So it's more of a little stream than a drip.
Hi, Andy. Then you should mention that it also runs on central heating oil.
Oh, yeah. Why Ian is saying that, because I have tried over the years running it on paraffin and kerosene and oil, and Ian there, he converted his house from oil, central heating oil, to gas. And I did a deal with him one year where I bought all the oil out of his tank and ran my boat. So it really does seem totally happy on anything. My preference is to burn paraffin. And we've got a builder's merchant near here that sells paraffin in bulk. So I take over 20-litre containers. He fills it up with paraffin. But I don't think there's a huge difference. I think probably paraffin is a little bit hotter. I think kerosene is in the middle, and heating oil is probably a little bit thicker. But to be honest, on a boat like this, I don't think it makes any difference. And if you can get it at the right price, run it at the right price. And I did a really good deal with Ian.
As is usual, all fees paid in wine.
Oh, dearie me. Did I miss that?
Right. Yeah. Adam, I think you've got a question. You might need to unmute yourself.
Okay. Can you hear me now?
No, we can hear you.
Yep, cool. Have you ever used diesel in it?
No, I haven't. No. To be honest, I've never needed to. If I ever ran out of fuel somewhere remote, I would go to a garage and buy some diesel. The thing that I don't like is that diesel is a much smellier fuel. I mean, kerosene is pretty smelly, but I think diesel is even worse. So no, I haven't. But I can't see any reason at all why it wouldn't work.
Yep, no worries. Thanks.
It was interesting. Dick Bradford was one of the probably fairly early on burners of kerosene, and he used to put a little bit of petrol in, probably just to increase the calorific value a little bit. I've never needed to do anything like that, so I haven't got around to doing playing around with fuels. I just buy whatever I can get and stick it in the boat, and away we go.
Yeah. And when you run paraffin, does it run with like the yellow flame, or can you get like a blue flame out of it?
It's interesting. There's one of our members, a chap called Jeff Kenworthy. He did some experiments with pot burners quite a few years ago, and he managed to get a blue flame. Now, I have never, ever managed to get a blue flame. You saw the flame that was on the pot burner earlier on. I get a yellow flame now. You would expect a yellow flame to produce smoke, but it doesn't seem to. It's
as long as you get that balance right, correct?
As long as you get the balance between the air and the fuel, and there is a saturation point that you can't go beyond. I've even gone to a bigger fan. Doesn't seem to make a huge amount of difference. The pot seems to be happy at its optimum. And I've not changed it. It just, because it works so well, I saw no reason to redesign it or do anything else.
Not broken, don't fix it, right?
Yeah, exactly.
Yeah, cool, thanks.
Oh, Ian, I think you have a question.
Hi, Andy.
Hello,
A question and a couple of quick points. The couple of quick points are experience up here. If in most areas you'll find companies that change and replace central heating oil tanks, they will sell spare surplus heating oil.
Really?
This is also interesting, I think, going forward in the longer term, that whilst expensive at the moment, you could be burning the hydrogenated vegetable oil diesel, which of course would then be completely green.
Yeah.
When we're facing all the challenges with coal and so on. But the question is a really stupid one. You've explained how the fuel vaporizes and then burns, but how do you get it lit in the first place, and how does it start to get hot and vaporize?
Right. Well, the way I do it is I put a single fire lighter in the middle of the pot. I crack the valve, and when I mean crack it, it literally is just so that a drip comes out, and I light the fire lighter. I leave that generally to like that for a few minutes, and then I experimented with having a rheostat on the fan so that I could reduce the volume of air, because one of the problems is while you're lighting it, you can actually blow the flame out. So I experimented with a rheostat, a speed controller, so that I could turn the fan right the way down low and let this little drip of oil start to burn. What I've ended up with is a resistance bank and just two positions, half fan and full fan. So when I start, I put the fan on half fan. It's just enough not to blow the fire lighter out. And after 5 minutes, you can hear the change. You can hear that the kerosene is starting to vaporize. And at that point, I increase the fuel a little bit. And once I can see that it is vaporizing and burning, I turn the fan on full and start to introduce more fuel. It's not complicated. It's just so simple. It's ridiculously simple, really. You think it ought to be more complicated, but it isn't.
And Andy, can I make a comment?
Yeah, go.
Yeah.
Okay, Andy, one of the virtues that I seem to have learned from your experience is that lighting up and getting started doesn't have the trauma of wood fires and coal and all of that. It's very quick. You can be off the jetty in minutes compared to almost an hour, you know. And what I think people would be interested in is that once you get what you've just talked about, I would call it the sweet spot of the burner. You can do anything you want, because the pressure will rise accordingly with the size of the flame. Yeah. And it's very, very, very convenient way of lighting a boiler and getting started.
Yeah, and the great thing is there's no kindling wood, there's no paper, there's no ash, there's nothing to clean out. But one of the things that really, I mean, I was very lucky in that for several years I've managed to keep my boat at Ian Rutter's on his garden. And the great thing I found is that when you come back from a few hours cruising, I don't have to wait for anything to cool down. I just turn the burner off and go home. And when I trailed the boat, as I do, I mean, I take it to SBA events, I can come back off the water, hook it onto the trailer and go home. There's no red hot. Nothing is red hot. And the dissipation of heat within the boiler is incredibly quick. So within half an hour, the boiler is, I wouldn't say completely cold, but it's only just warm. So there is no latent heat that stays in the boiler. That might be one of the downsides, that with a fire, you've got a lot of latent heat within the whole thing. And with oil, you've got no latent heat. So while it's running and burning, you've got heat. Turn it off, you've got no heat. But you've got no ash, no mess, nothing to clear up. It's painless. And I think, you know, now I'm paying, the last lot of paraffin I bought was 98p a litre. And I think there was, so call it £1.05 or something a litre. And I'm burning 2.25 litres an hour. Now, if you look at coal now, particularly if trying to get hold of the Welsh steam coal, whereas I think oil probably 5 years ago was a little bit more expensive than burning. Sorry, oil was more expensive than burning coal. I'm guessing now that if it's not on par, oil could even be cheaper. So to me, it's the way to go if you've got a boiler that will work. And that, I think, is going to be the Achilles heel of the SBA really encouraging more and more people to try and burn oil. It's because so many of us were running vertical fire tube boilers. And unless someone came up with a burner that will work on a fire tube boiler, it's going to be the Achilles heel. I don't see a way around it.
Yeah, I would agree with that wholeheartedly.
And I'm guessing now, I was talking to John earlier, that to build that boiler, my boiler, from scratch, you're not going to get any change of 10 grand. In fact, I think it's going to be more than that. You know, just having that brass dome made and polished, you know, it's just telephone numbers. And I think, you know, if I sold Aurelia now, I would be lucky to sell it for, well, let's be optimistic. Say I got 12,000 for it, which is more than any boat like Aurelia is going for at the moment. That means the whole boat is worth less than the new boiler. It's soul destroying.
Michael, I see you have a question. You need to unmute your microphone to start.
Yeah, I have a comment. I have a boat with a vertical fire tube boiler, and I run on oil. The difference is that I use an electric burner. It's similar to a regular household oil burner, except it's 12 volt. It takes about 12 amps while it's starting, which, you know, takes 15 seconds or so, and then it drops down to about 9 amps. So it's not too bad. And I have a rigid canopy, and I have a small solar panel up there, which makes about half as much electricity as the burner uses. So I can go out, you know, for extended length of time as long as the sun's shining.
Yeah, I did some research on what we call Riallo burners. Riallo is a UK company that does these domestic burners for boilers. And there is a company in the north of London that makes a 12 volt burner to go on a lorry to heat bitumen. And it's very similar to a Riallo, but it is designed for 12 volts. But it's £750. My pot burner probably costs less than 100. It's well, less than 100, probably less than 50. I tried to get the company to sponsor me. I actually said to them, look, the SBA really do want to do this research to transfer from coal to oil. Will you give me one of your burners at a big discount so that I can do all the experiment? And I got a very firm no. But that's the only company I come across in the UK that makes a 12 volt vaporizing burner. And that one actually draws about 12.5 amps all the time, which means you've got to carry such a big battery. It's hey ho.
Right. Al, I see you have a question. You'll need to unmute yourself to...
I'm sorry, Brian, this has gone on a bit longer than you wanted. Are you okay here?
Yeah, no, it's fine. In fact, they're talking about the Riallo boiler. Roger Eyes has joined us now from South Africa at the moment, and he's sent me some pictures of his setup, so he'll talk us through those shortly.
Oh, excellent.
Thank you very much for the talk. I think this is very interesting. I have built a pot boiler, but not done quite as much measurements as you have. What I did find was that the initial mixture of air and the oil vapor is what causes the yellow flame. And once the air gets to it, the yellow flame goes away because it gets enough air and it actually burns. And so you do get the efficiency that you're talking about, which all works very well. There are a few people in the US that have 12 volt, what we call Beckett burners.
Yeah, Beckett. Yeah.
A normal household heating burner, except at 12 volts. And they work pretty well, but they run, you got to have more than 100 watts of solar panels to break even. If you have a full-size car battery and a 100 watt solar panel, you can make it through the day, but you'll be needing to charge overnight. So the pot burner definitely uses less energy or less electricity. And I run a 100 amp hour battery in my boat with for just lights and bilge pump. But you're right. You don't want to have to truck it up the hill or dig it out of from under the floor to charge every day. But thank you very much. Very nice talk.
Oh, thank you.
Right, Roger. I think that's maybe the point where we have your points.
Let me take my pictures off, Brian.
Yeah.
Say here. There we go.
Right, Roger.
Hi, Brian.
I'll share you.
All right.
Yeah, we can see you. I'll share your overview.
Yeah, could you put up slide picture number 6, please? Sorry, folks. I'm trying to.
Right, I'm not sure that's number 6, is it?
No, that's not it. We'll come back to that in a moment. It's yellow flames and blue smoke. Yeah, next one. I think. There we go. I just thought. I'm sorry, guys. I came in late, but there's some talk about yellow flames off the burner. My name is Roger Heisey. I run a boat called Etna. Come back to that. But just starting on this picture, this is not a yellow burner. It's something else. It's one I bought in the SBA auction years ago to get to know oil burners. And this is the thing running in free space and produced a lovely yellow flame and a huge roaring noise and lots of blue smoke. And the neighbors were saying, "Oh God, what is he up to now?" The interesting thing, when you put this sort of burner into a boiler with a slight back pressure, the yellow flame goes away and you get a blue short flame off the front of the burner. So it is all a question of the burner being set up to be operating with the right amount of air for the back pressure off the boiler. Anyhow, Brian, can you go to picture number 1?
Right, I'm not sure which. Let's have a look. Just shout when you say, is that number 1? Oh,
keep going. No, it's right at the very beginning. There we go. Oh, back one.
Back one.
So let me speak briefly about Etna, and then Brian's asked to talk about the operational experience of oil fanning. Etna was commissioned in 2015, so 10 years ago, and this is a picture while I was putting it together a couple of years before that. She's about a strip plank hull, about 8.3 meters waterline length, a couple of 100 kilograms dead weight. Starting from the back, she's trimmed along by a 600 by 500 millimeter 3-blade propeller. Sorry, guys, I work in metric. Driven by a LIFO 15 horsepower compound in the middle of the picture. Steam comes from a LIFO style boiler, which was built about 14 years ago, 3-drum, 100 tubes, water tubes, with about 90 litres of water in there. The heat comes from a Riello G20 2-stage electric burner, which is a 12-volt burner driven through, a 230-volt burner, off-the-shelf job, run from an inverter. This was the, I think, long-term cheapest solution because it's off-shelf component, easily serviced, spares are quickly available. The inverter is relatively inexpensive, and the inefficiency of inverters are so high that you worry about it. So it was all off-the-shelf components, basically, and plug and play, put power to it, and it went. I carry two whacking great traction batteries at the back of the boat, each 110 ampere hours. I needed 70 kilos of ballast to trim the boat properly, so the batteries were just the job. I don't cart them up the hill. I've got a battery charger built in the boat. But as you see in the foreground of this picture, the white thing is an alternator driven off the engine. Okay, it absorbs a certain amount of power output, but not really materials for cruising. But as long as I keep a speed of about 6 or 7 kilometers an hour, I will make good on a trip. And I've been on week-long rallies without connection to the grid, and I've been able to provide myself enough electricity. The burner is at the other end of the boiler. I'll show you a picture of that in a moment, firing back towards the passengers. And the burner itself is under the seat in the front cockpit and acoustically fairly well insulated. You don't hear it, basically, and above the general clatter of the engine, it can't be heard. Right, what's to say? I've got a 2.6 gallon per hour nozzle in the burner, and that provides adequate steam for motoring along 6 to 8 kilometers an hour. It is a two-stage burner, and it will that pushes up the fuel throughput to about 3 gallons, US gallons, I should add, which at the end of the day gives me a nice cruising speed on Windermere, 6 to 8 kilometers an hour, at about 6 to 8 liters per hour. Sounds a lot, but she is quite a big boat, and I may have 6 to 8 people aboard. So, spread over the passenger load, it's quite a reasonable fuel consumption. Barry, can you just spin forward and find a picture of the boiler? Somewhere.
Yes.
Or maybe it's number 1.
I seem to have, just bear with me a minute.
Yeah, no problem.
Stopped scrolling.
Sorry, I had to pose on Barry because I'm a bit out in the boondocks here. I wasn't sure I could actually send the pictures.
Just have to stop sharing a minute, Roger, and go to the.
Fine.
Okay. It's the one with the boiler front.
Yes, on the wheels.
I have it. Just let me share that again.
No, and I just the design of Etna and her plant is nothing original. I was living in Germany for a number of years, and this style of heating and boiler is quite, I wouldn't say common, but that I can think of 4 boats with this configuration, and I just shamelessly copied their idea. The LIFO boiler, here's a picture of the boiler being commissioned. It's standing on those legs with wheels, just as a useful workshop assistance. Basically, the 2 mud drums and the steam drums out of view at the top, but the burner is just configured to sit coaxially or between the 2 mud drums and fires into a sump, which is a steel half cylinder, which fits fairly tightly. There we go. Up between the mud drums and produces a gas-tight seal. One of the requirements of this configuration is you've got enough depth below the center line of the boiler there for the burner housing. That's probably the biggest problem, I think, with packing an electric burner of this type onto any boiler, is you've got to have enough depth to get the chassis of the burner down in the hull. But as you can see, there's just a small hole into the boiler. You stick the nozzle of the burner in there. The insulation I made slightly fat around the hole, and it produces a gas-tight seal. So, in fact, in the 10 years of operation to date, I've had no singeing of the hull around it due to gas leaks or exhaust leaks. Right. The operational experience I've had with this boat essentially is that, like, I've had a 100% of availability. There have been only a few occasions when I've been left stuck, as it were. These electric oil burners are absolutely idiot-proof. They fire up when you apply power to them, or they don't fire up when something's wrong. And the result is that I think Etna's had a rather boring reputation of being the boat that always goes. But so primarily the advantage I find of oil firing, and I should add that in the 10 years before Etna, I had another boat, coal-fired boat by the name of Vesuvius. No surprise that the new one's called Etna. That was a typical coal-fired steamboat where you had your ups and your downs and could spend as much as an hour lighting it. With Etna, we're away in about 20 minutes from getting aboard and switching the switch on. Okay, some people may say that you've actually ruined the fun because it's just like having a motorboat. But it does, I suppose, depend what you're looking for in a boat. I wanted a boat that works. I have no fuel issues. Fuel is sort of universally available, and basically, I have a couple of 20-litre plastic fuel cans, and I just pick up some diesel on the way to the boat when I'm heading up to Windermere. I've tried. You sometimes use central heating oil or red diesel. But the hassle of filling out the HMRC forms or the prices which Marina charges you for red diesel means it's a no-brainer. It's much simpler to pick up road diesel and burn that. And the other advantage of even a 20-litre canister of diesel is it weighs less than 25 kilograms of coal. And you can siphon it into the boat without having to heave the bag up over the gunwale. So from the point of view of old man steaming, oil is really is a no-brainer. But the most striking thing about using oil, I find, is it's clean, essentially. The boat is clean, clothing's clean, even the inside of the funnel is clean. And we had the 10-year boiler test last summer. I stripped the boiler down, and would you believe it, the white lagging inside the casing was still, reasonably white. It does burn clean. These central heating burners have been produced in their millions to work and to not pollute the atmosphere. There's no ash, as Andy said. Also, I find there's no smell. The modern burner burns the fuel so completely, and it always goes basically, with the exception of a few faults I've had. Certainly, the first public hiccup of the boat on one of the early trips was I ran out of fuel because I have a rather. And here, Barry, could you just run through the pictures so you find a picture of the control box?
Yes, I think I'm quite not a skill problem here with
No, don't worry, take your time.
Let me, the control box, that's the one with the meter on it.
That's right.
Right, I can share that. Oh, no, that's not right, sorry. Can you see these pictures I'm scrolling through?
Yep. Keep going.
Right, I think that's the one you're after.
This is something which most steamboaters will.
Sorry about that. It seems to.
Don't worry. Gives you heebie-jeebies, but that's the control box. No, it's not.
Oh. There we are. Sorry.
There you stop. There you go. That's the control panel on that. No, it doesn't look like the thing that should be on the steamboat. There you go. That meter also tells you everything: boiler pressure, fuel level, and so on. But unfortunately, I got the calibration curve wrong initially on the fuel tank, so I had actually nothing in the tank when I thought I had 20 litres left, which did show to me that interestingly enough, the oil burner would self-prime once I filled the tank. And so running out of fuel, but that was only on the first trip, got the calibration right. There've been one occasion when the burner failed or appeared to have failed after a road trip, and all that had happened was the electronic panel on the burner had vibrated loose and just needed to be reseated. This is something to note on these central heating burners. They are not designed for use in circumstances where there's high vibration levels. So one does need to add the odd cable tie to some of the loose components to make sure they don't jiggle off. And I've had a couple of spurious errors due to water and condensation getting into the connectors on the central heating burner. Again, these things are not designed for use in a maritime environment, and the connectors are basically crap. So I swapped out the cheap connectors which were on the burner and replaced them with waterproof mil spec ones that solved them completely. The other things which I've noticed is a picture just to illustrate my point. There's a fuel filter somewhere if you find it, Brad. But if you use diesel,
sorry about this. Here we are. That's the one. Share that. Right, does that look like a filter?
If you're going to burn, there's a picture that shows you, well, the filler pipe into the tank. But if you're going to burn something like diesel, put one of these in a fuel filter, because you get interesting life, and perhaps not to be known, but biofilm grows in the interface between diesel and water. And this is an interesting gooey sort of stuff, which is probably used by the food industry to make your ice cream stiff, but it can block the burner nozzle. So do put a filter in and swap it out regularly. This is a vital addition. And just as an observation, make sure that where your fuel lines are running, where there could be any leak, make sure you've got the wood surfaces sealed, because the last thing you want is to get your woodwork impregnated with diesel. That can produce quite a serious fire hazard. But my operational experience with the oil is don't burn anything else, frankly. It is so convenient. Andy's mentioned things like no ash, just switch off. I can just switch off and I'm in a lock instead of fighting the boiler and water level. I just turn the burner off. And you come at the end of a rally, turn the burner off, pull the boat up on the trailer and go home. Yes, go for oil, basically. Whether you burn it, the pot burner or with an electric burner, whatever sort, it's just a no-brainer. I can't say anything more, but I can answer questions.
Thank you, Roger. Yes, same as last time. If you put up your hand icon, then that's probably the best way to order things.
Nope.
No, I noticed the common theme on filtration.
I'm sorry.
I noticed the common theme on filtration with Andy,
Yes.
so that was. Right, I think we've probably got time. I've done a few slides on. I'm taking the role of heretic on the solid fuel, which I tried out not on a boat on my steamroller, but just by way of contrast, which I can just go through. Ooh. Right, I don't know if you can see this, but there's a company relatively local to me that's making briquettes out of oilseed residue, and I expressed an interest in this, and they gave me a sample to try out. And this is just a brief description of what I found. If I can get my PowerPoint to move on. Oh, where are we? Doesn't look quite right, does it? Oh, there they are. Found the controls now. So, yeah, that's just there's a place in Nottinghamshire that's producing briquettes from oilseed residue called Phoenix Speciality Oils. They they produce vegetable oils, and the residue from their pressing normally goes to cattle feed, I think, but they have been trying to sell it as a fuel. I tried two sizes of briquette. There's a 6-inch rule to show what sort of size they are. The greenish looking things that have come out of an extruder. And I compared those with house coal sold, I think it was sold last year or the year before now by CPL, which they told me originated from Poland. And obviously the background to that in England, you can't burn house coal in houses anymore. So this is about the methodology. I tried it in three stages of operation that I identified. The initial steam raising, which took to about 25 pounds a square inch, raising the pressure from that to blowing off pressure, and then on a short journey of around 2.5 miles. This was the evaluation tool, which is my steamroller. It's effectively well worn, I think, is a condition, so it may not be the most efficient machine about, but it was the same boiler and engine and same route that I tried both the coal and the briquettes on. So in terms of what I found, so initial steam raising used around 30 kilos of coal, about the same in the briquettes. So my feeling is it's comparable in natural draft situations. I didn't quantify the second phase between 25 pounds a square inch and 140 pounds a square inch blown off pressure, but subjectively, I think the coal was more responsive and quicker in that situation. And then I made a short journey with each of the fuels. albeit short, with a steamroller that proceeds at a stately pace. There's enough running to get into a reasonably steady state. I think where considerably more of the briquettes were used, and in fact, only the smaller briquettes would generate enough heat for continuous running. The large ones wouldn't support continuous running. So my evaluation was that for initial or steam raising or low demand steaming, then the oilseed residue briquettes seem comparable to house coal in the locomotive pattern boiler. In terms of building up the pressure to blowing off pressure, they seemed a bit slower. And under the high demands of the steaming with a forced draft, then the consumption was significantly higher than the coal. But with the smaller briquettes and careful attention, continuous running was possible, which with the larger ones it wasn't. I think there were a few other considerations. Generally, the smoke was much lower with these briquettes, or under natural draft was hardly visible. Whereas with the benchmark coal, which was just normal bituminous house coal, it was generating quite a lot of smoke. However, after running with high draft and building up the fire, and then stopping without letting the fire die down, there was heavy smoking from the briquettes as well. The briquettes give away their origin in oilseed because they have a faint aroma of a chip shop about them, or the smoke does. And interestingly, when they were stored, they seemed attractive to some sort of vermin that gnawed through the sacks and had a bite of them. And the other interesting thing I found with the briquettes is they didn't seem to like to propagate the fire laterally like you can with coal. You had to put the briquettes on top of lighted ones to get them to light, which surprised me a little bit. I think that's so. In conclude, whoops, I think I'll stop sharing. Yeah. Can you see my screen again?
Yep.
Yeah. So I guess in conclusion, for low demand, these oilseed residue briquettes seem comparable to house coal. When there was a high demand, the consumption was significantly higher than with house coal on the weight basis, and they need a lot more careful management to keep up with the demand. And that was just my few points on a solid fuel.
Brian, how did they compare on price?
I think they're quite a lot more expensive now. I got them to because I think they're about I asked them to quote for half a ton. These ones I had were free, but half a ton was about 350, I think, pounds sterling last year. I think it depends a little bit on the animal feed market. They'll sell them for animal feed if that they can get at a price, so it links to that. Al, I see you've got a question.
Yes. Did you have to use a blower or anything when you were using the briquettes? Because it seemed like you were using a lot more for that than to get the fire started. Was there anything different in the steaming?
Yes. Effectively, it's a locomotive boiler with the exhaust turned up the chimney. So effectively, it's under quite a heavy draft once it's running. So that is the big difference between the static, where it was just by natural draft, and the running. And under those forced draft conditions, that's where the consumption went significantly higher than with coal. Roger?
Brian, what about the volume? And can you get enough briquettes in the firebox to produce enough heat?
Yes, I think that's compared with some other biofuels, then it seemed okay in that respect, albeit the drop off in performance. But effectively, maybe there's some experiments to do in the technique, but the bed wasn't significantly thicker than with coal, the fire bed, as I had it. And in fact, the things char more or less as soon as you put them on the fire, and they don't look that dissimilar to coal. It's not like low value residue. Like I've been to sugar mills where they've used briquettes of the sugar cane waste, and there they seem to stack the firebox up to the crown with the briquettes to get a locomotive to run on it. It's quite amazing how they can cram them into the box. But certainly above the level of the fire door.
Yeah, I was just thinking of times when I've been burning wood on Vesuvius on the continent, and frankly, I had to fill the boat with wood to get enough to get steam for a day.
Yeah, I think they might be slightly more energy dense, but because I must admit I was quite, when you think about it, because they're not as dense as coal, to use the same mass as coal is a slightly bigger volume, but it's not massively bigger. And I don't think it was noticeably, or it was for a short journey, it wasn't difficult to put the coal in the bunker, and it wasn't noticeably different from put the briquettes in the bunker, and it wasn't noticeably different from running on coal in terms of the space for the fuel. Right. Well, I think we've come to the end of the presentations. Unless there's any further discussion or any points on fuels, or maybe there's.
Thank you very much.
Oh well, thanks for
very well
joining.
done. Very interesting. Thank you.
Thank you. Well, thanks for the presenters and Andy and Roger for giving us their experience. I'm hoping this will be saved as a recording, which should be available in due course on the website. And I'm hoping to have a further one in March, probably late March, on lubrication topics. So I'll circulate shortly on that. Anyway, I'll bid you all good night, or I don't know if it's still good afternoon in the Americas.
Good morning down in Australia.
Mornings. Yeah, sorry. I have to look at perspective on my part. Yeah, morning too. Right, I'll close the meeting. Thanks a lot, everybody.
Thanks, Brian. Thank you.
Thank you. Thanks very much.
Bye now.
Bye.
Bye.
Thanks. So John Wynn has been to Lee's Mills several times, but